Okay, hope it gets recorded. Yeah, you are recording and ochindi, so it is recording, I think. Okay, I'm going back. Okay, right here. Okay. Now, in this case, we are considering n number of waves coming out from the single slit of slit width D, of slit width D. Okay. And when we consider the rays that are going at an angle theta after diffraction, then the path difference between the first ray and the last ray is d sine theta. Okay, when d is the slit width, the path difference will be d sine theta. Now, if I have to convert this path difference into phase difference, then the phase difference capital phi is equal to d sine theta into 2 pi by lambda, d sine theta into 2 pi by lambda. Okay. So I have considered n number of waves to be coming out from the slit. Then d, resultant amplitude of those n waves which are moving at an angle theta is given by this arc, okay, chord length AC. When ABC is the superposition of all the n number of amplitudes A naughts, that means n waves coming out with amplitude A naught. So all the waves with A naught amplitude, when they are superimposed to give the resultant amplitude AC, which can be expressed as AC can be expressed as n A naught sine phi by 2 by phi by 2. Now, how did I get that? Because this AC is 2 times of AE and this AE is R sine phi by 2. AE is R sine phi by 2 and this phi by 2 is half of the phase difference between the first ray and the last ray, and this phi is as such equivalent to d sine theta into 2 pi by lambda. This phi is as such equivalent to d sine theta into 2 pi by lambda. Okay, so we got the resultant amplitude as AC. Now our question was to find the intensity distribution. Intensity is nothing but a square of the amplitude. Okay, and amplitude is nothing but n A naught sine phi by 2 by sine phi by 2, where phi by 2 is taken as alpha. So this is n A naught sine alpha by alpha whole square. That will be the resultant amplitude. If I take n A naught whole square as I naught, then the intensity distribution is given by the expression I is equal to I naught sine alpha by alpha whole square. Okay, that's a simple mathematics of it. Okay, where alpha is equal to phi by 2 and phi is equal to 2 pi by lambda into d sine theta, or d sine theta path difference into 2 pi by lambda, the phase changing component. Okay, good. Now, is alpha a variable or a constant? Look at this screen and tell me. Okay, is alpha a variable or a constant? 5, 4, 3.
Constant.
Alpha is a constant. Why? Pi is constant, lambda is constant, d is constant, and theta. Okay. Now theta, if it is a constant, alpha is a constant. If theta is a variable, alpha is a variable. Okay. Now what is theta? Do you remember what is theta? You remember that is theta? Theta is the angle in which the light rays are propagating with respect to the original direction. Basically, the light rays are propagating in all possible directions. But I am considering what happens to the rays which are going in a direction theta with respect to the original direction. Okay, so theta is something which is in my hands. It's a variable. Okay, so from this expression, alpha is dependent upon theta. Alpha is dependent upon theta. Okay. Now, when theta is equal to 0, that means in the original direction, when theta is equal to 0, in the original direction, what is the intensity? What is the intensity value? Please respond. 5, 4, 3, 2, 1. What happened? If the light rays are going undeviated, that is theta is equal to 0, then what is the intensity for those light rays?
Infinite.
Yama?
Infinite.
Answer is wrong. Good try, but answer is wrong. Yeah. Somebody else?
0.
No. Okay. I'll give you the mathematics of it. Okay, mathematic part that you have just forgotten. Okay. What is limit sine alpha by alpha as alpha tends to 0?
1.
Okay. So mostly you will be forgetting that. Okay, limit sine alpha by alpha as alpha tends to 0 is 1. Or okay, limit sine theta by theta as theta tends to 0 is 1. Okay. Yes or no? Okay, from that consideration, will you please tell me when theta is equal to 0, what is the value of I?
I naught. N naught.
Good.
N.
Yeah, n a naught whole square. Okay.
Square.
Yeah, right. Okay. So, is that understood or not?
Yes.
Okay, good. Next question. As theta increases, what happens to I? As theta increases, what happens to I? What happens? Okay. Now we are directly going to the expression. Wait, check on. Yeah, what happens? Yeah, tell me. Emindama, what happens?
Increasing.
As theta increases, I value decreases. As theta value increases, I value decreases. How can you say that, sir? Because for theta is equal to 0, alpha is equal to 0, for that I value is maximum. After that, as theta increases, alpha increases. When alpha increases, sin alpha may increase. But what is the maximum value of sin alpha? 1. Okay. But as theta increases, alpha also increases. So alpha is there in the denominator also. Because of which the value of I decreases. Okay. Now, and because you have sin alpha in the numerator, what happens is, after the principal maxima, as alpha increases, that means as theta increases, when alpha is equal to pi, you will get minimum. After that, again there will be increase. Okay, at 2 pi, you will have another maxima. Again, after 2 pi, there will be a continuous decrement. And again, increment. And again, decrement. So the numerator says that I value will increase and decrease and increase and decrease. And alpha in the denominator tells you that it continuously decreases. Sir, which one is correct? Does it increase and decrease, or does it continuously decrease? Both of them will take place. That is, the alpha value will be okay, the I value will be decreasing, okay, increasing and decreasing and increasing, but this increment will be, okay, let me show you the graph. Okay, right here. Okay, I'll go back, okay, for the mathematics of it. See, this is the central maximum when alpha is equal to 0. This is the central maximum when alpha is equal to 0. So as alpha increased, okay, the I value decreased and became 0 when alpha is equal to pi. And after that again it increased, and again after that it increased. But that increment did not go to the maximum of I. Now what is this value? This is decreasing because you have alpha square in the denominator. Because of the alpha square in the denominator, this I value got decreased here. Okay, and you further increase the value beyond that, then the numerator is decreasing, so it becomes 0 again at 2 pi. And when you further go up, again its value increases. Okay, I mean at this value you'll have highest maximum, that is that's what you call as 2 pi plus pi by 2, 2 plus pi by 2, that is 5 pi by 2. Okay, at 5 pi by 2 you will have another maxima. Okay, but this maxima is not as much as the previous or not as much as the first original. This is the central maxima. Okay, hope you have understood. Okay, now let us try to give a mathematical, okay, expression for these conditions. Okay, now what you see here, all this is your I, okay, A, capital A, n A naught sine alpha by alpha, n A naught sine alpha by alpha. Okay, and I'm considering, okay, it is a wave. Initially I considered it as only the amplitude. I have considered it as an amplitude. Okay, now if I consider it as a wave, then amplitude into the cos term, so y is equal to a cos omega t, where a is nothing but n A naught sine alpha by alpha. Okay, and what is alpha? You have already seen. Okay, pi d sine theta by lambda. Okay, so this can be written as y n A naught cos omega t, or n A naught sine alpha by alpha. Okay. Now, okay, this is not right. This is not right. Okay, this is y is equal to n A naught sine alpha by alpha into cos omega t. Okay, y is equal to n A naught sine alpha by alpha cos omega t. Okay, this term, okay, replaced over here. Okay, this is sine alpha by alpha cos omega t, same, right? Now AR, okay, this should have been AR. Okay, not n A naught, but it should have been AR cos omega t. That AR is nothing but n A naught sine alpha by alpha. Okay, now intensity distribution is given by I is equal to I naught, that is n square A naught square. I naught is nothing but n square A naught square sine alpha by alpha whole square. This is the intensity distribution expression. Okay, now when do you get, okay, what is the condition for maxima?